examples on differentiation. You can check them on YouTube. I've uploaded some of them on YouTube. Yeah. In fact, there's a lot of them on YouTube. You can get any information that you need. The basics, the applications of differentiation, everything. Yeah. So if you need more info, just search for Tech. You'll get more examples there. Yes. But otherwise, do you guys have any question? Do you guys have any question? Any assignment question? Any question? No question. Okay. Then I'll just continue with differentiation. So I already showed you how to differentiate that 2.1. I did some examples that are similar to 2.1. So the one that I'm gonna do today is uh, it's similar to 2.2. So 2.2, you've got logarithmic differentiation there. It's logarithmic differentiation. This one is not complicated. As long as you know how to use the formula sheet, it's easy. For example, let's say you've got ln x. So they will say y is equals to ln x, for example. Then they say differentiate. If they say differentiate, guys, sometimes they can say differentiate, or sometimes they can say find dy over dx. You must know that they want you to differentiate. When they say find dy over dx, you must know that they want you to differentiate. It's the same as saying differentiate when they say dy over dx. So for this one, guys, I'll just let me do this. From your Telegram, let me just do this. From your Telegram, there's previous question papers there, if you noticed. So you just go to files, you get one previous question paper, a random, you can pick any. You'll just get a formula sheet there. There's a formula sheet, but the formula sheet that they are using, it's the formula sheet that they are using, it's a these guys, they keep on adding me to this forex things. Oh, the formula sheet that you guys are gonna use, it's different, it's integration, is the integral one. So it's up to you. You can even download this tutorial letter. I think it has this one, number 2. I think it has the formula sheet as well. You can use any as long as you can be able to see the formula sheet. So this one that we are using here, it only has table of integral. I already showed some of you how to use that table of integral. Is this the tutorial letter? Nah, this one doesn't have a formula sheet. So yeah, just get, even in your study guide is there. In your study guide, if you check on your study guide, there's a formula sheet as well in your study guide. So if you can use that study guide number 2, this one, you'll see the formula sheet there. You can even use study guide number 2, number 1, no. You can use study guide number 2. So I just want to show you how to use this formula sheet. If you don't have study guide number 2, you can use this one. If you scroll down to differentiation, you see here, it says formula sheet there. You've got the formula sheet there. So this formula sheet, it goes chapter by chapter. It goes chapter by chapter. You see trigonometry, you've got everything. So the one that we want is the, you see the differentiation. This one is, we're not gonna use it that much. I still owe you guys the quotient, and I already showed you the product rule. If you're not here, this is the formula for product rule. Product rule, I already touched that chapter or that topic, sorry. Product rule. I already touched that one. So the one that we're gonna do is quotient. Quotient is the one that you use on 2.3. I'm gonna show you how to do it. 2.3, that's quotient. But now I want to do lean first, then I'll do quotient later. So for lean, I told you guys that if you're using the table of integral, this table, that's the one that you're gonna get in your exam. So if you're using this table of integral on the left hand side, where it says 1 there, you see that sign that looks like S. It's a integral sign. So differentiation, we don't want this sign. So meaning our differentiation is on the right hand side. Whatever you have on the right hand side is your differentiation. So integration and differentiation, they're reverse of each other. You're gonna see when we do the integration that these are opposite or reverse of each other. They're inversely proportional. So um, so we're gonna look for lean. You see the lean on the right hand side. They said differentiation. You can write on top there on your notes. You can write that on the right hand side it's a differentiation. So when they say find dy over the x of lean, x or lean something, you must know that you ignore that c plus c, ignore that plus c. Don't consider that plus c. Only take lean f of x. So from this example, lean f of x. So this thing is the same as lean f of x. Lean f of x. So they said it should give you, you check on the left hand side. On the left hand side, they said,
Sorry.
Yes.
Yeah, before we can go furthermore, can you please go back to question one, asymmetry, elaborate more in 1.2 and 1.3? I don't know where to start. How can I take it? Maybe you can give me an idea.
I already touched that one. You can download the session. Is there. I uploaded everything on the group today.
Which group?
The maths group, this one.
Okay, okay.
Here's the recording. This one. Let me show you. Mm, is this one. I uploaded, I think it was yesterday. Yeah. This one. There's two files there. There's two sessions there. You see? There. You click here,
Okay, okay.
and then you download. Please download them before 7 days. Otherwise, you're gonna have a problem after 7 days. Hey, guys, may assist. Please help. I don't know if you encounter this something like this. I don't know what's happening there. Yeah, but I'll try to also upload them on the YouTube. I think I should upload them on YouTube because it's easy. It's accessible. Yeah, I think I should upload them on YouTube because on YouTube I've uploaded, or let me show you. So you can check here, guys. Let me show you. There's a lot of videos that are uploaded on YouTube that can assist you. YouTube. There's a lot of videos that I uploaded. You can go to YouTube if you need, especially for differentiation and integration. There's a lot of them. This will take time. Okay. While it's still loading, oh, there. You just search for Cognier Tech. Cognier caps. Search for Cognier Tech. This one. There's a lot of videos. I even put them in folders. You see, you just go to here, you click there, then you go to playlist. You see there's engineering mechanics, there's engineering maths. This is your maths one. I'll upload a lot of videos even on N5. You can get differentiation and integration on both. So there's differentiation. You go to N5, there's differentiation as well. You see, differentiation of inverses. There's a lot, guys. Yeah, you can go there. You'll see the a lot of information, even for mechanics, for those who are doing EME 1501, even for Maths 3, yeah, all of them. Everything is there. So if you need more info, you can just go there. I'll upload more videos, just that, yeah. So let's go back to the question. So lean f of x, I'm doing 2.2. So if you look at lean f of x, they said it should give you the answer. I said it's on the right, on the left, I mean. So you're gonna get f prime over f of x. Ignore the s. I'm showing you how to use this formula sheet. Ignore that s and dx. So you only consider this part. F prime over f of x. Ignore dx and s. You'll only use it if you are moving from the left to the right. If you are integrating. When I say left to the right, it's when you're integrating. But if you're moving from right to left, you're taking only this part from the right hand side, you only consider lean. Then on the left hand side, your answer must be f prime over f of x. This is what I'm saying. Let me write it down. So your answer must be f of x over f prime over f of x. And then you ignore that dx. Ignore this dx and that sign, the integral sign. So this is what you're gonna get. Always, I told you guys, if you're here last week, I told you that you must multiply by the f prime of x. There's a reason why I'm doing this. There's a reason. Let me show you. So basically, this thing, that f prime of x that is here, normally it's not here. So they multiply by it. That's why it's there. So normally this thing is 1 over f of x times f prime of x. It's like this, normally. But you know that this is the same as f prime of x over f of x. Is the same. So this is what you're gonna do. Let me- So this is what you're gonna do. You're gonna take your f of x. What is your f of x from that from this question? What is your f of x? Anyone? What is your f of x from ln x? Whatever that is in front of ln, that's your f of x, guys. Whatever that is in front of ln, that's your f of x. So you're gonna take this x and then say you write it down. Always you identify your f of x first. That's the first step when you differentiate. So you're gonna write down your f of x, which is x. And then I'm looking at this, the answer. This is your answer. This is what you must get. This is your answer as your reference. So they said you must find f of x. After finding f of x, you must same time you must differentiate. That f prime means differentiation. That means differentiation. It means dy over dx for those who don't understand it. So we're gonna differentiate our x, this one. You're gonna take this one and differentiate it. So to differentiate this one, for those who are not here, this is raised to the power 1, it's x to the power 1. So this is the same as x to the power n. So you're gonna use formula number 1 that says ax to the power n. This is the formula, ax to the power n, ax to the power n. So when you differentiate this, you will get your f prime will be n ax to the power n minus 1. That's the answer that you're gonna get. So we can plug it here. We can write our f prime on the left hand side. So your f prime will be equals to 1 times x to the power 1 minus 1. Then here you're gonna get x to the power 0. What is x to the power 0? I told you last week on weekend, on a Saturday, I told you that anything to the power 0 is 1. Whether it's 2 to the power 0, you can punch it on your calculator. 2 to the power 0, it's 1. 1 to the power 0, whatever you have to the power 0, it's 1. So our f prime of x will be equals to 1. Then now we can go back to the question. We can say ln f of x is equals to 1 over f of x times f prime of x. And then we can say, you write it like this. When you differentiate, you say dy over dx. They said you must differentiate with respect to x. That's the question. So the moment you write dy over dx, that's when you write your final answer. You cannot write that dy over dx if you didn't differentiate. The moment you say dy over dx is equals to 1 over your f of x, f of x was equals to x multiplied by 1. That's when you put dy over dx. You put it when you differentiate. Before you differentiate, you don't put it. Let's say, for example, let's say you had x squared over 2x. They said differentiate this. Before you can differentiate this, you have to simplify it first. For as long as you are still simplifying, you don't write dy over dx. You'll only write dy over dx after simplifying. So you're gonna do this here, 1 over 2, and then you say x squared over x. You group them. You simplify this first. When you simplify this, dividing the parts of the same base, you subtract the exponents. So you're gonna have x there. Then you haven't differentiated yet. You're still simplifying. Then from this step, that's when you can write dy over dx, meaning you are differentiating now. Meaning you are differentiating now. Then when you differentiate, that's when you write it down. You're gonna have this. Then you're gonna be left with 1 over 2. That's your answer. That's how you differentiate, guys. I was just showing you. So for our answer is this one. For that one for lean. For lean f of x, your answer is this one. It's 1 over x. Any question? Any question? The general question you can ask a question from the assignment. I'll guide you. I won't give you the answer. I'll just guide you. Any question? All right. Means you guys are sorted. So example number 2, I'm gonna do the same example as the one for lean. Let's say you've got lean. Now I'm gonna change my lean. Let's say it's lean 2x squared, for example. Lean 2x squared. So from this, you can write this as lean f of x. Then they said it should give you 1 over f prime of x times f of, sorry, not f prime of x, 1 over f of x times f prime of x. So first step, I told you to identify your f of x. F of x is the one that is in front of your lean. That's your f of x. Then you're gonna write it down. F of x is equals to 2x squared. Same time, you find f prime. All the time, you must always find f prime. So how do you differentiate this? You're gonna take this and write it in the form of this. You're gonna say this is the same as ax to the power n. Then when you differentiate this, you're gonna get n ax to the power n minus 1. So your answer, you're gonna write it as f prime here. You're gonna write your answer here. So what is your a? Your a is 2. Your n is 2. And then x to the power 2 minus 1. Then your answer will be 4x. This is your f prime. Anyone who doesn't understand? Anyone who's lost? Okay. So from here, you can write dy over dx. The moment you write dy over dx, it means you are applying that formula for 1 over f of x times f prime of x. That's when you write it. That's when you write it. Okay? Hey, what did I do now? So the moment you write 1 over f of x times f prime, that's when you're differentiating. So then you write your answer. You write 1 over f of x. What is your f of x? You write that 2x squared, then you multiply by 4x. This thing can be written as 4x over 2x squared. Then you apply that rule that says dividing the parts of the same base, you subtract the exponent and then you divide the coefficients, the numbers. So you're going to say 4 over 2, you're going to get a 2. Then you say x to the power 1. Remember, you're dividing x and x squared. You're dividing x to the power 1 and x squared. So dividing the parts of the same base, you subtract the exponent. So this is the same as 1 minus x. So you're going to get x to the power minus 1 here. So it's x to the power 1 minus 2. Then this, you write it nicely. You can write it as 2 over x. This will be your answer. This will be your answer. Any question? Any question? So I already showed you. In fact, I already gave you the answers. Okay, yeah. For those who noticed, yeah. Okay, let's move. Let me show you this third example, the last one. So you've got y is equals to. By the way, what is the differentiation of 2? How do you differentiate 2? What is the differentiation of a constant? How do you differentiate a constant, a number? But guys, I showed you. This can be written as x to the power 0. X to the power 0 is equals to 1. So if you want to differentiate a number with respect to x, like if you've got 2, for example, or 3, or any number, to differentiate it, there's x to the power 0 there because x to the power 0 is the same as 1. So this is the same as 2 times 1. So instead of writing 1 there, you write x to the power 0. You consider that as 0. Then if you apply that x to the power 0, you'll see that you've got AXN, where your n is 0. N is equals to 0. So your constant is always 0. When you say dy over the x of a number or a constant, you'll get a 0. Why? Because your n is 0. So if you noticed, if you apply that rule that says a, it says n times a x to the power n minus 1. If you apply it, that's your differentiation. If you differentiate 2, you're going to get 0, which is your n, times 2 x to the power 0 minus 1. The reason why it's 0 is because of that n. For as long as your n is 0, when I say n is 0, is that one there. For as long as your n is 0, this n, your constant will always be 0. So dy over the x of a constant will be 0. Whether it's 1, whether it's 5, whether it's 3, whether it's 8, for as long as it's a number, guys, whether it's 100, as long as it's a number, it's 0. Able. So I'm gonna do the last example now. So lean, for example, square root of x plus 4. This one, it's easy. You just take this. I'm not sure. That's your f of x. You write it down. Please mute your mic. Please mute your mic. Okay. So that's your f of x. You write it down. F of x is equals to square root of x plus 4. Same time, before you can differentiate it, you can't differentiate this square root. You have to change it to exponential. So this is what you're gonna do. You're gonna write it as x to the power 1 over 2 plus 4. You write it like that. Then same time, you differentiate. Because remember the rule for integrate for differentiating ln. For differentiating ln, they said ln f of x is equals to, when you differentiate it, you must get 1 over f of x times f prime of x. So that's why we have to find, let me wait guys, please hold, let me mute the mic. I can't find the person whose mic's on. I can't see. Oh, right room. Okay, there you go. This one. Okay, I think it's muted now. So yeah, so guys, you're gonna find the f prime. So when you differentiate this, the first one, you're gonna start with that, this one. You differentiate them one by one. You differentiate that one, you're gonna get 1 over 2 x to the power 1 over 2 minus 1. Then you go to the next one. What did I say about a constant? I already told you that when you differentiate a number, you'll get a 0. I showed you just now. So you'll get a 0. So you write it nicely. You say 1 over 2. Then you say 1 over 2 minus 1. So you're going to get minus 1 over 2. X to the power minus 1 over 2. Yes. Then you go back, you plug it there. So you're going to write dy over dx is equals to 1 over f of x times f prime of x. Then you plug in your values. So you're going to have 1 over f of x. What is your f of x? You write it as it is. You write square root of x plus 4. And then you multiply by the f prime, which is 1 over x to the power minus 1 over 2. Guys, you see this right here? You can write it in a positive exponent. So to write it in a positive exponent, let me show you. So if you've got 1 over 2 x to the power minus half, if you want to write it in the form of a positive exponent, you can split this and say 1 over 2, open bracket, 1 over x half, which is the same as 1 over 2 square root x. So you can write it that way if you want as your final answer. In fact, just write it that way. Just write it as 1 over 2 root x over your f of x, which is x plus 4. That's your answer. Don't try to simplify it further. If you write it this way, that's your answer. This is your answer. Any question? Any question, guys? You don't have any question? Okay. Since you don't have any question, let's move to. Hi, hello.
Okay.
Yes, I can hear you.
Hello, can you hear me?
Yes, I can hear you. Yes, I can hear you. Can you hear me?
Okay.
Yeah.
For the question that you just did now, even
Yes.
above that one.
Okay.
Yes.
Let me go to the slide. And this one.
Can you hear me?
Yes, I can hear you. I can hear you.
No, not this. Before this one.
This one.
Yes. Yes. I wanted to ask. Here you got 2x to the power negative 1.
2x to the power. Okay.
And you
Yes.
said we must use the rule. Said we must use the rule of, if we're dividing same basis, then we subtract the exponent, right?
Yes.
So is it not is this 1 minus 2?
Yes, it's 1 minus 2.
which becomes negative 1.
Yes, that's
Which
correct.
become negative 1.
Yes,
Okay, but then, oh, okay, I got it. I got it.
you got it.
Thank you.
Okay,
Yeah.
not a problem. Not a problem. Can we move to the next one? Any other question before I move to? I'm gonna do question now. Question is the one for 2.3. So I'm gonna show you how to do question. I already showed you question one. Question 2.1. I mean question 2.1. It's a product rule. 2.1 is a product rule. We already covered product rule. Then 2.2, it's the one that we're doing now, the logarithmic differentiation. Then the one that we're gonna be doing now, it's quotient rule, quotient, quotient rule. So guys, quotient rule. So quotient rule, so quotient rule is this formula. Let me show you the formula. This one. I'm gonna go up to differentiation. The one that I said we're gonna come back to it. Formula number 5. That's your quotient rule. That's your quotient rule. So quotient rule is like this. They say if you have got values that are dividing, I already explained the introduction. So you've got g times, sorry. So you'll have f over g, for example, f over g, f of x over g of x. So basically, you'll have something that is not dividing. You won't have x squared over 2x. This one you can divide. You'll have something like this, ex over x. You can't divide these two. That's why the other one is your g, the other one is your f. Because there's functions, you cannot divide them. So one is will be your g, one will be your f. So you can't divide the two. That's when you use a quotient rule. Quotient rule, division. It's when you are dividing functions that are not divisible by each other. That's what that's what you can write. And then for product is the same, but product you are multiplying the ones, you are not multiplying 2x times x. This one you can multiply. Rather, you're multiplying x times e to the power x times x. That's your product. That's your product. The ones that you cannot multiply, it's your product. And the ones that you can divide, it's quotient. So that's the one that we're gonna do now. That's the intro. So this is what I'm gonna do. I'm gonna do this. This is what I'm gonna do, guys. Um, for example, I want to do something that will help you. So if we are dividing, for example, this is the question: y is equals to the one that you've done, ln x over x, for example. You see, you can't divide these two. In fact, let me just say, yeah, x will work. So if you get a question like this where you can't divide the two functions, this is what you do. You go to the formula sheet. You look for this quotient rule. If you check there, on the left hand side, that's your question, f over g. So the top one is your f, the bottom one is your g. Let's write it down. So the top one is your f, the bottom one is your g. Then they said when you differentiate this on the right hand side, it's a differentiation. They said dy over the x of this, you must get this one after the equal sign. You must get g times f prime. You must get g times f prime, then minus f times g prime, minus f times g prime, divided by g squared. This is your answer. So basically, this thing is telling you what to find. You already have g, you already have f, and then you already have g. The unknown is f prime and g prime. So it means you're gonna have to go and find the f prime and the g prime so that you can substitute them on the formula. So this is what you're gonna do. Start with f. So just say f is equals to ln x. Then find f prime of that. I already showed you how to find the f prime of this. When you differentiate this, you must get 1 over f of x. Where is your f of x? Is that one there, times the f prime of x. It's easy. It's easy, guys. Just do it the way I told you. To differentiate this, you want to get 1 over x. Already showed you how to do that. That's why I was doing that introduction. It's very important. And then we go to g now. I'm going to write down g. G is equals to my g, it's x. Then what is the g prime of x? How do you differentiate x? You know that it's to the power 1. Then we're going to use that ax to the power n is equals to n ax to the power n minus 1. This is when you are dy, you are finding dy over the x. Is the same as your g prime. So to differentiate that, you're going to get n. What is your n? It's 1. So you're going to get 1 for this one because you're going to get x to the power 0, which is 1. So by the way, if you want me to show you the steps, you'll get 1, which is your n, I mean, x to the power 1 minus 1. So you'll get x to the power 0. So you can write down here, g prime is equals to 1. Then we go and say dy over the x. They said we should get g times f prime minus g prime times f over g squared. We substitute those values here. So our g, we write it down, it's x, times our f prime. You must know your f prime, it's 1 over x. You see there, x times 1 over x minus your g prime. What is your g prime? It's 1. Multiply by the f. So f was ln x. You divide it by g squared. So what is your g? It's x squared. You see? G squared, x squared. Then you simplify. Here, when you multiply this, they're going to cancel. X and x are going to cancel. So you're going to be left with 1 minus ln x. Because that ln x is multiplied by 1. This ln x is multiplied by 1. So you're going to get 1. Then you divide it by x squared. Then this will be your final answer. This will be your answer. Any question? Any question? Are you guys still good? Okay. So now, guys, so I'm gonna show you another one. Another one, I'm gonna use E now. I'm gonna use E. Let's say you've got y is equals to, for example, e to the power 2x over e x. I want the one that cannot divide. ex plus 5x, for example. You see this? You can't divide them. You can't divide. So this is what you're gonna do. You're gonna use quotient rule. In fact, let me just yeah, nah, I think it's fine like this. So you can't divide, meaning the top one is your f, the bottom one is your g. Then this you identify your f and your g. So let's write them down. F is equals to e2x. Then g is equals to ex plus 5x. So same time, you're gonna have to find differentiation of that. I already showed you guys how to find differentiation of e. I told you that when you're differentiating e, I'll go to the formula sheet just now. When you're differentiating e, you take this one as your f of x. You go there to the formula sheet. If you go to the formula sheet under the table of integral, you look at the one with e on the right hand side. E f of x, you see that top one, the top one. I said you must ignore c. So the top one is your f of x. The answer is this one without dx and what. So they said your answer must be f prime of x times e f of x. So the answer for here, they said it's f prime of x times e f of x. So what is our f of x? I already told you that for this question, let me erase this one for now because we're gonna need space. For this question, your f of x is 2x. So this tells you that in order for you to find this, you need to differentiate that 2x. You're gonna get 2. So the answer, the f prime, will be 2e 2x. That's your answer. This one represent this because that f of x is 2x. So when you differentiate 2x, you're gonna get a 2. So you multiply by it there. Understand? Do you guys understand it? Okay. If you are quiet, it means you understand. Ex plus 5x. It's easy. You do the same thing. You do the same. You start with ex. What is the differentiation of that? It's easy. That ex will give you 1 multiplied by ex because your f of x in this case is x. Differentiation of x is 1. That's why I put 1 there. And then you go to the next one. You say plus. By the way, this is your g prime. This is your g prime. Then you go to 5. What is the differentiation of 5? 5x. You use that formula that says ax to the power n. Ax to the power n minus 1. Then differentiation of 5, you're going to get 5. Differentiation of 5x, I mean, you're going to get a 5. Okay. So you go back and put them here. They said it's the answer you should get g prime. They start with f prime, sorry. They said it's f prime times g minus g prime times f over g squared. You can substitute there. You write dy over the x now is equals to f prime. You write that 2e 2x times the g. What is your g? Your g, you write it as it is, ex plus 5x. You minus, you can use the brackets there to show that they are splitting. You minus the g prime. What is your g prime? It's ex plus 5. Then you divide, you minus the g prime times, you see there I have to use the brackets. There's no other way because it's g prime and f. So I have to write the whole of f. So f it's e 2x. Then you divide everything by e x plus 5x squared. You can leave it as it is. There's no need for you to simplify it. You can leave it as it is. And that will be your answer, guys. That will be your answer. Any question, that's how you're gonna do it. That's how you're gonna do that 2.3. And yeah. So let me see if there's still more questions. Yeah, there's a lot of questions. Up to question 3. Yeah, but this weekend we're gonna have to do at least a 2 hour session or 1.5 hour session so that we can push all the other questions. Yeah. Any question, guys? You don't have any question? Okay. Uh, so if you want to join the WhatsApp group, there is a link there. I posted the link there. There's a link for WhatsApp there. If you can see it there. Otherwise, yeah, please, if you want to join, you can join using that link. And also for those who are doing mechanics, is it mechanics EME 1501 or PHY 1501? I'll also arrange a session for that module this week. So yeah, if you want to join, you can click there. I'll update you guys. So see you on Saturday at 12. Yeah, your session will be at 12 for maths.